we're going to work with negative and fraction exponents. Okay, so we have two sets of rules here. Sure, we'll go over the negative exponent rule because I think it's relatively simple. Whatever the base is, if it's to a negative exponent, negative 8, it can be rewritten as, whenever you have a base or a whole number, you can think of it like it's over 1. You essentially just invert the fraction. So now the 1 comes on top, and it's important now when it's on top, so we have to write it in. Where on this side, when we divide by 1, it's irrelevant, it doesn't do anything. We have 1 divided by x to the positive a. Okay, so we essentially just turn into a fraction and flip it if it's a negative. And if it's already a fraction, we just flip it. That's all there is to it. Okay? Fractional exponents are a little different. They work with something called roots. And you've probably seen this before, a square root. And there's usually nothing written here. And when there's nothing written there, it's actually assumed that the number 2 is there. It's called the square root. And that tells you how many values you're trying to multiply to find the number underneath. So the square root of 25, well, I need 2 numbers that equal 25, and they happen to be 5 times 5. That's why 5 is the square root. Okay. If you're looking for the third root of, that's an easy one, 2, 4, 8. 8. I'm looking for 3 numbers that multiply by themselves to make 8. Well, that's 2 by 2 by 2. Okay, so that's what those mean as roots. So a fractional exponent can be written as the denominator is whatever the root is. Okay, so if this denominator is 2, then it's the square root. If the denominator is 3, then it's the cubed root, or the root of 3. And whatever the numerator is, or the value on top, you just make the base to that power, or you put it through the root first and put the base to that power after. It doesn't matter the order. Okay? A lot of funny rules. We're just going to try to walk through them. Okay? So we're just going to try to make everything positive exponents. So the very first one, how do I write 5 over 1 as a fraction?
5 over 1?
Oh, I just said it, jeez. 5 over 1. 5 as a fraction is 5 over 1. Perfect. So if I want to make this a positive exponent, how would I rewrite this? What would I have to write it as?
1 over 5.
Yeah, exactly. So now it's 1 over 5 to the power of what?
2.
Yeah, positive 2. And we're done. And now it's a positive exponent. We got it. Okay. Tactically, I can simplify farther. If I did this, I'd have 1 over, and 5 to the power of 2 is 25. 1 to the power of 2 is 1, so 1 over 25. Okay. Let's try to do that. We'll try to go over the end. This one here, we want to make it a positive power first, so what do we do to it? How would I rewrite this?
Make it 2 over 3.
2 over 3, and now it's to what power?
Positive 3.
Positive 3, and now I can evaluate. 2 to the power of 3 is 8, and 3 to the power of 3 is 27. There we go. All right, the next thing, fractions. Okay, how do I write this as a root? This is difficult. This is a little harder. We know we're going to have 25 underneath, and we're going to have some root. What is the number here at the front of the root according to our fraction?
2.
Yes, we take the denominator, so we take our 2. And we can put it to the power of 3 after we've square rooted it, if we like. Okay, so 2 is a square root. What's the square root of 25?
5.
5, yeah. And then we have 5 to the power of 3. So this is equals. 5 to the power of 3 is 125. So now we evaluated it. Okay. This one here, a little harder. 64 is our base. What's the root of this one?
4.
4. Oh, shoot. I think I wrote this wrong. Because I don't think we get a whole number. I think I wanted that to be... I need that to be 3. I'm going to change that fraction just so this works out another way. I wanted this to be 4 over 3. Okay, 4 over 3. So now what's the root 2?
3.
Yeah, so it's the third root. Okay, and again, it's probably easier if we root it first and then put it to that exponent after. Not always, but it can be. Just because if we were to do the 64 to the power of 4, it's a huge number. So in our capacity, it's probably not. It's not. The third root of 64. It's a tough one. Do I have third roots on this? I can on my calculator. I can go 64 to the power of, and the third root I can write as 1 divided by 3. I'm essentially writing a fraction as a power, and it gives me the number 4. So 4 times 4 is 16, times 4 again is 64. So that works out nice. Third root of 64 is 4 to the power of, and then 4 again. Okay, and that's going to be a relatively large number. I think it's going to be 256, I think. So let's check it. 4 to the power of 4 256. Now, just to prove that we could have done the 4 first, if we have done 64 to the power of 4, so 64 to the power of 4, huge number, and then we got the third root of it, okay? So we take our answer and put it to the third root, 1 divided by 3. We get 256, the exact same answer. It doesn't matter the order, just one way is usually a little more efficient. Okay? Finally, we have a negative fractional exponent. I want to make this positive first, so what am I going to do?
Flip the fraction.
Okay, so what's it going to become?
8 over 27.
Okay, so we get 8 over 27. Okay, what's it to the power of?
2 over 3.
2 over 3, okay. So now this is technically the base. What root is this to? It's 8 over 27. What root is it to?
The third root.
Third root. And then we will square it after. Okay. So, a fractional root, think of it like I'm finding the third root of 8 and the third root of 27. Okay. The third root of 8, do you know what number multiplied by itself 3 times makes 8?
2.
2, yeah. So that becomes 2 over, do you know what number multiplied by itself 3 times makes 27?
3.
3. 2 over 3. Okay. Equal 2 over 3 to the power of 2. We can figure this out. What's 2 to the power of 2?
4.
Yeah, and 3 to the power of 2?
9.
And there you go. So this very complicated one, since we knew our rules, simplifies into 4 over 9.